Hello all. This is Catherine Sanchna, a PMRF PhD scholar from IIT Madras. Okay, this is for the 11th week, and I guess we will be having one more week, and then after that, a revision session also, which the time and date of which will be announced later, maybe by the NPTEL team. Yeah, this video will be posted on YouTube, and if you have any queries, you can either write in the discussion forum of the NPTEL website, or you can comment in the below the YouTube video, okay, corresponding YouTube video. So let us begin now. So if you remember, last week we were seeing about intersection layout, okay, and we, as usual, we had some questions left behind carried over to the next week, and so we will solve those questions first, and then we will move to the next topic, which will be design of facilities. Okay, so here I have taken previous year's NPTEL questions. Okay, so without any further delay, let us begin with the first question. Okay, so the first question is, a divisional island has been constructed for diverging of traffic from a road. If the approach speed is 80 kilometers per hour, then the approach length in meters of the island leading to an intersection would be what? So the first question is, what is a divisional island? It is nothing but something similar to a median. Okay, it is an island on the road which serves for a dividing purpose. You know what road islands are, right? Say on a road, if you have let us say I have an intersection like this. Okay, in order to have a streamlined flow or to avoid conflict points, I can make this as a Y intersection with a channel in between, right, to make the flow streamlined. Now, this is an island. Similarly, when you have a rotary interchange, right, here in the middle you will have a rotary island, right? So this is a channelized island, this is a rotary island. In the same manner, you will have a divisional island, okay, which serves to divide the road. So if this is the road, okay, meeting another road, okay, then you can provide a division here for diverging the traffic. Okay, so this may look similar to a median. In fact, it can be median in many cases. Okay, so this is the divisional island. Now they are asking you, now the question is, just a second. Yeah, so the question is, what should be the approach length of the, so now this divisional island, they are saying that it is provided at an intersection. Okay, it is provided at an intersection, okay, to align the traffic. Now this length, they are asking you how much this length should be. This is called as the approach length, and they are asking you how much this approach length should be if the approach speed of the vehicles in this arm is 80 kilometers per hour. Okay, so the answer to this will be, if you see sir's slides, it is a straightforward problem. If you see sir's slides, you can find that the approach length is nothing but the length corresponding to 3 seconds of travel time. Okay, now you have the speed, you have the time, you have to find out the distance. In this case, this distance is the length. Okay, so what it means is if a vehicle is approaching at a speed of 80 kilometers per hour, then it should the length of this island should be such that it should be equivalent to 3 seconds of travel time of the vehicle corresponding which is traveling at 80 kilometers per hour. Okay, so how will you find the length? Length is nothing but 3, this is in seconds, and what you have, speed is in kilometers per hour. So you have to convert this to meters per second. Okay, only then seconds and seconds will get cancelled. So how will you convert kilometers to meter? Kilometers to meter, it will be into 1000. And how will you convert hour to seconds? You have to multiply the denominator by 3600. So if you see, so if you see this, the answer to this is 67.67 meters. Okay, so the answer is 66.67 meters. Now moving on to the next question. While channelizing an intersection, the following should be considered. So just now we saw what a channelized intersection is by giving an example of a Y intersection, right? I told you that this is a channel island. Okay, now they're asking you, if you're planning to channelize an intersection, what considerations should be made. Now there are a few considerations. One will be the design variations of the island should be studied to finalize the most suitable island for the traffic movements. So the shape of the island changes from location to location, right? And for a given location there can be various shapes of the island. So you have to choose a particular island such that it will suit the traffic movements of that place. Okay, one thing. So point number 1 is it will depend upon the traffic movements of the place. Then you should make sure that there are not multiple islands in a single place, right? So if you have something like this, you should not go with multiple islands. Okay, multiple islands like this, but you should make sure that it is a sorry, my diagram is very poor. Okay, so you should not go with multiple islands like this. You should try to ensure that it is occupied by one large island. Okay, so this is one criteria. The other thing is, this is an island, right? So it should have, so let me draw cross-sectional view of the road. Okay, this is the level of the road. Okay, top surface, and on top of that you will be having the channel with a curb. Okay, most of the times it will have a curb, and this curb should be provided on all important roads and important intersections on 2-lane roads. Okay, so it should have a curb, that is it should be raised when compared to the level of the road if the roads are important. Okay, and you should not use very high curbs, okay, with angled iron frames. So you have to provide curbs but not very high curbs. And then in case of a divisional island, what we saw earlier, the approach width shall allow the smooth movement of traffic. Actually, this session is being provided this Wednesday, that is on 11th of October. We did not have any session on Monday, which is on the 9th, because of academic reasons. I had some work here, okay, some exam here. So I asked the NPTEL team to postpone it, and they also mailed me that they postponed the session. And I'm not sure if you've been informed of it, and I think that is why no one is there in the uh, call. But still, I will continue this because anyway, this will be uploaded on YouTube. If at all you have any doubts, please feel free to post in the discussion forum or in the comment section in the YouTube video. Okay, so yeah, what were we saying? So in case of divisional island, so if it is a divisional island, then it should allow smooth movement of traffic, and you should make sure that drainage will not be a problem when you construct the island. Okay, because say you would have provided the road with a slope. Okay, and this island should not hinder the drainage of um, runoff water. Okay, that is rainfall water. Okay, so now from these three, from all the points that we saw, let us see which one suits this question better. Okay, so while channelizing an intersection, the following should be considered. So should you consider directional movement of traffic? Yes. Should you consider drainage requirements? Yes. Should you consider need for illumination? No. Should you consider road markings for delineation of space? Yes, obviously yes, because you will have, say you have an island here, okay, and it is kind of raised, right? Raised when compared to the other surface. So you have to provide road markings, okay, to delineate the road from the island. In some cases, they would have provided studs also, reflecting studs, right? If your vehicle light shines on the studs, it will get reflected back, and you will be able to see the clear demarcation. But this should not be confused with illumination. Illumination is different. Providing reflective studs is different. Okay, so the answer to this is A, B, and D. Moving on to the next question. Yeah, so vehicle's direction will change by 270 degrees if they traverse through a what? So first let us understand under what context this question is being asked. So this is asked for a interchange with ramps. Okay, so we saw that if we last week we saw that at an intersection, if you are not able to if you want to provide the highest level of safety, then you will go for an interchange, and this interchange can be either with ramps or without ramps. So if it is a with ramps, it means that two roads are crossing each other at different levels, but access to one road from the other will be provided with the help of ramps. Okay, ramp roads. What do I mean by interchange without ramps? It means that two roads are simply crossing one over the other, but the access to each of the roads is provided somewhere else, not here. Okay, they are just crossing one another here. So this question stands for interchange with ramps. Now let us see this example, because they have given you different terms. I have taken a figure from IRC 92, which is for design of interchanges. Okay, so that you can connect the terms that they've given here, and you will be kind of able to relate seeing this figure. So first let us understand what is a direct connection. Now let us first understand this figure. It is a trumpet interchange, right? Now it has many ramps, and okay, so all these are used to provide access to the roads, right? If you're traveling in this road, if you want to access the other road, you've been provided with this it this ramp. Similarly, if you want to access this side, you've been provided with this ramp, right? And yeah, and here you should note that as per the note that they've given here, the direct ramp is not a part of the trumpet interchange, but in order to show you what a direct connection is, they have just given you here as an example. And if you are traveling on this road, if you have to go to this side of the road, then you are provided with a semi-direct connection. And if you're traveling in this road and you have to kind of go to this side of the road, you're provided a loop. Now let me take this figure again and try to show you clearly where each direction connects. Now if you let us imagine you're traveling on this road. You're traveling on this road and say that you want to go left. Okay, you have to turn left. Which way will you go? They've already provided you a route here, which is the diagonal connection, right? What does this diagonal connection mean? It is like a diagonal of a quadrilateral, right? So if you want to move left, go left, you just travel through this path. This is called as a diagonal connection. Okay, now let us say you're traveling again in this same road and you want to go to the right. Now you have two options. This is just an example, okay? This is not exactly a trumpet interchange. They told you that trumpet interchange will not have a direct connection. So this thing is just imaginary. So in order to move right, there are two options for you. Either you can take this road, which is this direct connection, and go this way to the right, or there's one more way. You go straight, take the loop, and then go right. Anyway, you've been directed to the correct direction, but the way how you are directed is different. One way is direct connection and the other way is loop. Both these will not be provided for the same interchange. They'll provide only one. Okay. Now, what is the difference between these two? One is you want to go right. What will you do? Intuitively, you will look for a road which is there on the right to you, which will lead you to a road on the right. That is direct connection, because I want to go right and I am directly directed towards the right road by just taking a right turn. I want to go right, so I take a right road. That is direct connection. Now, if you see this loop, this is tricky because you want to go to the right, but in order to go to the right road, you have to make a left turn, right? So this is called as indirect or semi-direct. So you're not directly, so in order to go right, you're making a left turn, and this will be confusing obviously, but it will reduce the number of conflict points. So if you see, the more number of left turns you make, the less number of conflicts you have. If you take this direct interchange, obviously you will be having a conflict point here. But when you go through this loop, you will never face a conflict point anywhere. Okay, except for this merging and diverging conflicts, which can be considered as minor conflicts, you will not have any cross conflict with the other vehicles when you take a left movement, when you make a left movement always. Okay, so if you have a left movement, it means that you have the highest level of safety in that interchange. Okay, so what did I tell you now? This is a loop, and in order to make the right turn, you took the loop by making a left turn. Okay, and you were again directed to the right road which you wanted to go. Now so you are in this road and you saw how a person traveling in this direction was able to go to the left and right. Now let us take the other road. So let us take this road. Now imagine that you are traveling in this direction and you want to make a right turn. Okay, if you want to make a right turn, then again here you are making a left turn and you direct it towards the right. So this is right, this is left for this vehicle, right? So in order to make a right turn, you are taking a left turn and then you are brought back to the right direction which you wanted to go, right? Now just a second. Now you're traveling in this direction and you want to travel to the left. This is easy. This is just by taking a diagonal connection, just as how we saw here. Okay. Now yeah, so you travel in this direction, you can either go to the right or straight. If you travel in this direction, you can either go to the left or straight, and we saw both the directions, right? So this is done. So we understood what a direct connection and a semi-direct connection and a loop stands for. So it is just to direct you to different roads. Either it will direct you directly by taking by asking you to make a right turn if you want to go to the right, or or it can direct you semi directly or indirectly by asking you to make a left turn in order to go to a road on the right. Okay, now the question that they've asked is completely different. So what does the question ask? Vehicles direction will change by 270 degrees if they traverse through a water. So what does this question mean? What is, so they've asked you how if they travel through which connection will they make a 270 degree turn. So what do I mean by a 270 degree? If my vehicle is in this direction, if I want to make a right turn, this is my 90 degree turn. Okay, now if I want if my vehicle is traveling this direction and if I make a right turn and then I come back, okay, this is a 180 degree turn. 180 degree turn, right? Because I'm traveling back in the same direction. 90 here, again 90 here, 180. Now what is 270? I'm traveling in this direction, I make a right turn, I'm traveling in this direction, and then I'm traveling again here. Okay, so this is my, so 90 plus 90 plus 90, so it will give me 270 degrees. Now from all these connections, let us see which will give me a 270 degree turn. Okay, so it is like my vehicle travels here, goes right, comes back down and then turns left to get the 270 degree turn. So let us see which direction will give me a 270 degree turn. Okay, let us first take a diagonal connection. So when you travel on a diagonal connection, the vehicle which is in this direction goes to this direction. So what is this? It is a 90 degree turn. So this is not the answer. Let us take a direct connection. Okay, so when I travel through a direct connection, the vehicle which is traveling here goes to this direction. So here, from here to here. So this is also 90 degrees. 90 degree turn. So direct connection is also not the answer. Now semi-direct connection. A vehicle which is traveling in this direction, after traveling through a semi-direct connection, goes by in this direction, right? So vehicle traveling in this direction goes to this direction after traveling through the semi-direct connection. So this will also give me a 90 degree turn. Now the last one. What does this loop tell you? A vehicle traveling in this direction goes to this direction, right? Traveling. So how will it go? If it is traveling through the loop, let us say it is traveling in this direction, then it takes the loop, then again it comes down again to the same road and then goes in this direction. This is what we saw, right? 90, 180, 270. So when you travel through a loop, your vehicle will make a 270-degree turn. So this is the question, and the answer to this is loop. Okay. Now moving on to the next question. A, B, C and D represent locations where merging and diverging takes place on the two intersecting highways of a clover leaf interchange as shown in the figure. Sorry. Yeah. So, what is a merging and diverging? So, first let us understand what a clover leaf intersection is, and then let us understand what merging and diverging is. So, you should know what a clover leaf intersection is. So, if you are a person from Chennai, then you would have come across this clover leaf intersection, and it is popularly called as the Katipara intersection. Okay, so the Katipara is a clover leaf intersection, which you see looks like a clover leaf. It provides the highest level of safety. Why? Because wherever you go, you will make only left turns. If you want to go to the right, you will make a left turn. If you want to go to the left, you will make a left turn. And I told you a few minutes back that left turn movements are the most safe, are the safest movements. Okay, because right turn movements will result in conflicts. So this clover leaf provides the highest level of safety, and but it requires a large amount of space. So this is a few lines about clover leaf. Okay, but it has a lot to it behind this. Let us now that we've seen what a clover leaf is, let us see what merging and diverging is. You know what merging is, right? So you are okay. This is a road, okay, in which vehicles are traveling, and you are trying to enter this stream. And what will you do? You will try to merge into the stream. So this is the merging action. It will create a conflict point with the vehicle which is traveling in this direction, but it will be only a minor conflict, right? Now what is a diverging action? You're traveling now you're traveling on this road, and now you want to leave the road. Okay, leave the road or leave the lane. Maybe you want to travel from you want to shift from this lane to this lane. This is called as diverging from this lane and merging into the other lane. Okay, or if you want to leave the road, then you will diverge and go out. Okay, so this will also create a conflict point, but again it is a minor conflict point. Now they are asking you, where on this clover leaf intersection can you see merging and diverging actions? They have given you 4 points A, B, C and D. Now where will you see merging action? Let us say, so if you see, let us see this figure. You need not look that intently into the figure, but I just want to explain you with this figure. That is why I am showing you these vehicles that okay, these are traveling in this direction. So they are traveling on the right lane, which means it is a figure obtained from maybe US, I don't know. So okay, so it does not have a left left maintaining vehicle. So it is, the vehicles are on the right lane. So if you see, vehicles are moving along the right lane, they are coming here, and from this road, which is at the same grade as the level surface, it tries to attain a higher level by traveling through this loop and entering here. So when it enters here, okay, let us say from the loop it enters here, what it will do, it will try to merge into the traffic, right? So this here from A to B, it will have a merging action, right? Now if my vehicle, so yeah, if it will have a merging action. Now let us say my vehicle is traveling on this lane, okay, this lane, and it has to go to a lower road, lower road at a lower level. So it will come out of this road and enter the loop. What it does, it tries to leave this road and enter the loop, which means it is diverging. The vehicles are diverging at this place, right? So from A to B, just a second, just a second. Yeah. So in this length of A to B and B to A, you will have merging and diverging actions. Maneuvers, sorry, merging and diverging maneuvers, right? Similarly, go to the other road, C to D, right? The vehicles are traveling on the right lane, right? So for this vehicle here to come to a road of at an other level, then it will travel through the loop, and then it will enter the section which will create a merging action. And from here, it will again travel through this loop and enter, which will create a diverging action, right? So in C to D also, you will have C to D and D to C, you will have a again merging and diverging action maneuvers. Okay, so the answer to this will be A to B, B to A, C D and DC. That is only along this stretch and this stretch you will be having merging and diverging actions. Other stretches, if you see, other one is AD. AD, you will not be having any merging or diverging actions. The vehicle entering here will simply go travel through the loop and then enter the main section. So if you check for other figures, other things also, others are just loops. Okay, so merging and diverging will always take place in this straight section. Now till here, till this, it was just last week's questions. Now moving on to this week's question. So this week also we have some questions on interchange layout, and then we will go to design of facilities. Okay. So for the first question, examine the following statements regarding conditions that warrant interchanges. So you cannot provide interchanges wherever you want. Just because two roads connect each other or cross each other, it doesn't mean that you have to go for an interchange just because you want to reduce the number of conflict points. Because interchange is a costly process, you have to make sure that the place actually warrants or requires an interchange before you make the decision. Okay, so there are few criteria which you have to ensure that this place has achieved, okay, in order for it to have an interchange, okay, to warrant an interchange. And so what is that? Obviously the first point will be, if the traffic is high, then you will go for an interchange, right? So first point will be traffic high, but how much high? You have to quantify it, right? For you, high traffic might be something, and for me, just a second, I'll just charge my laptop. So how much high? For you, high traffic might be different, and for me, high traffic might be different. So you should assign a number to it, right? So if the total traffic on all the arms, what do I mean by all the arms? In all the directions is greater than 10,000 passenger car units per hour. I hope you remember what passenger car unit is, because it is the design vehicle for traffic, right? So if total traffic on all arms is greater than 10,000 PCU per hour, then you can go for an interchange. Next, if you want to provide complete access control. So what do I mean by access control? We saw this earlier. You will not allow the vehicle to enter or leave the section as and when they want, but you will control the access of the vehicle to that particular road. So that is called as access control. You're controlling the access of the road. Okay. So you will not enter any vehicle to enter anywhere. Okay. So you will tell the vehicle that you have to enter only at this point. So that is called as access control. So if you want to go for an access controlled standard, then you have to go for a interchange. And most important point is, if the crossing roads are both if both the crossing roads are major roads, then you will go for an interchange. Okay. And one more criteria is, if the crossing roads if the crossing roads are not major roads as in close to expressway major, but they are arterials but with still heavy traffic, then you will go for interchange. So either your crossing roads have to be major roads such as expressways, or it can even be arterials but the traffic volume has to be high. And one more important point is, if you see that at this place you encounter a lot of crashes or accidents, then you can go for a interchange. And finally, it all depends on the topography. So topography, depending on the topography also, you can go for an interchange. So based on the points which I told you, which I've collected, which I could observe from sir slides, and I explained it to you, we will see what will be the solution for this problem, for this question. So should it be developed because of major crossings on highway to expressway standards? Yes, we saw it is true. The total traffic on all arms exceeds 12,000 PCU per hour. No, we saw that the answer that the value is 10,000 PCU per hour. So this is wrong. Need to implement access control standards? Yes. And high number of fatal crashes despite implementation of improvement measures on at-grade intersection. This also we saw. We saw about crashes, right? So the answer to this is 1, 2 and 4. Now moving on to the next question. Select the correct statements with respect to the geometry features of ramps. Okay. So ramps, we saw what ramps are. They are connecting roads connecting. Okay. So they are roads that connect these two roads, which are at two different levels. Okay. They are roads provided at an interchange which connects the road on the lower level to that on the higher level. So if you see IRC 92, then they will have given you how to design these ramps. Okay, geometric design of these ramps. Right. So in such a case, so we will be going through some points and then we will check if this value is correct. Now, before I could say something about these points, we will see something in general about ramps. Okay, so ramps, I told you, they are roads connecting roads, okay, at two different levels. Okay, maybe I will take a picture from here. Let me take this. Alright, so um, this is a loop ramp because it is connecting roads at two different levels, right? If you see, okay, this is not clearly visible here. I will show you this figure. Okay, so this diagonal is also a ramp. This diagonal road is also a ramp. Here, here, okay. It just it is just for left turning movement. It connects the road, this road, to this road, okay, and they are at two different levels. So this is a ramp. So what can you infer from this? That ramp is a road with a gradient, right? It should have, since it connects roads at two different levels, it should have some gradient. Now what they say is the ramp will have a valley curve at the end, a tangent of constant slope in the middle, and a summit curve at the top. Okay, so this is the road at lower level, this is the road at higher level, right? So at the upper end it will have a summit curve, at the lower end it will have a valley curve, and in between these two curves you will have a tangent grade. What a tangent grade means? It is a constant slope, road with a constant slope. Okay, so this is how a ramp, the gradient of the ramp should be. Now one interesting point which I would like to explain is, why do they say that um, at the upper end it is a summit curve and at the lower end it is a valley curve? Let us say I'm so this is my ramp, okay. Say here this is my upper end and it has a summit curve, and this is my lower end and this is a valley curve. So if you see the definition of curve, you will understand why they call it as a summit curve or call this as a valley curve. So what is the definition of curve? What will your intuition say? If I'm traveling in this direction, then this part will be my summit curve and this part will be my valley curve, because here my vehicle is going up and here my vehicle again maybe will go down. So that will be your intuition. And if you're traveling in this direction, you will say that this is my summit curve and this is my valley, or maybe you will even say that both are valley curves, right? Because both are descending, you will call that both are valley curves. And here also you may call both are summit curves, okay, if you're traveling in this direction. But it is not the case. It does not depend on the direction in which you travel on your ramp. No matter which direction you travel, you will always have a valley curve at the bottom or at the lower end, and a summit curve at the upper end. I really wish I had someone here to answer these questions. Unfortunately, this message was not conveyed properly, I guess, and so I cannot find anyone here. But still, okay. So let us proceed. Yeah. So what is the definition for summit curve? It is just a curve, and where the two tangents, the grades which connect these two points, okay. If this has a positive n1, this will have a negative n1, n2, right? Because it is descending. If the deflection angle, which is the algebraic sum between these two, is positive, then it is a summit curve. If the algebraic sum of the two grades is negative, then it is a valley curve, right? Now let us come to this. If you're traveling in this direction, you will have a grade of 0, right? It will be connecting to a straight road, right? You will have a grade of 0, and then you will have a grade of, you will have a positive grade, plus n1, let us say plus n1. So if you find out the deflection angle for these two, n will be 0 minus n1, which is minus n1. That is why it is a valley curve. Okay. So let us say we travel here now. We have come to this point now. So here it has a positive grade of say n2 plus n2, and again here it is going and reaching a constant straight road which has a slope of 0. So what will be the deflection angle for these two gradients? It will be n2 minus 0. So it is positive n2, that is a summit, that is why it is a summit curve. Now I said that it will not depend on direction, right? I told that okay, this curve is connected to this curve, so 0 minus n2 is minus n2. You might think that since I'm taking it in this direction, my n2, my deflection angle is negative. It is not so. We will see how. Okay, so again we will take this ramp, okay, and this time we will come from here. Your first slope will be 0 and your this slope will be negative, right, because it is decreasing now. Now if you find out, this is my first slope and this is my second slope. If I find out the deflection angle, it will be 0 minus of minus n2, which will be plus n2. So this is a summit curve. Now let us come here. Here it has again a negative slope of say minus n1, and then it is coming and reaching a constant value or a straight road of slope 0. Now it is coming from here to here, right? Now what will the deflection angle be? This is my first slope and this is my second slope. So it will be minus n1 minus 0, which is minus n1. So this will be a valley curve. Okay. So as I told you, the position of summit or valley curve will not depend on the direction of travel, but it will depend on what we just saw. So and since we spoke about grade, we will see one point regarding that which comes in this question. So what they say is, they say that the gradient of this ramp should be a maximum of 4%, and in no case should it exceed 6%. Should not exceed 6%. Okay. So this is the criteria that they are given. Okay. Now moving on to the next point. So let us say my ramp, as you saw, either it was turning like this, a curve like this, or it was a loop, right? Which means it is a horizontal curve. In both cases it is a horizontal curve, and what we saw when we saw about horizontal curves, when you traverse along a horizontal curve, your vehicle will be pulled outwards because of the centrifugal force, because of which you will provide some super elevation. So your ramps should have super elevation, but the super elevation, what is the limiting value of super elevation that we saw on an at grade road? It should be maximum of 7%, right? Here it should be only a maximum of 6%. Okay. And why they are limiting it to 6% is because when you're traveling on a plain surface, when you make a turn, you will not tend to reduce your speed that much. Okay, because of which your super elevation has to be provided a bit higher, so that it can take care of the centrifugal force. But when you travel on a road whose level keeps decreasing, whose level keeps changing, you will be cautious, and your speed on your speed on this road will not be the same as your speed on the plain road. Your speed will be much lesser because you're cautious, you're scared, you're trying to be cautious. So in such a case, you need not provide that much of a super elevation, and so they are restricting it to 6%. Okay, so the desirable maximum super elevation rate on ramps is 7%. No, we just now saw that it has to be 6%. The absolute minimum value of the absolute maximum value of gradient on ramps is 6%. Yes, we saw that now. Okay, and here, third point, the profile of the ramp consists of a section of tangent grade with two vertical curves, valley curve at the upper end and summit curve at the lower end. Did we see it that way? No, obviously not. We saw that summit curve is at the upper end and valley curve is at the lower end. Okay, so this is again wrong. And side distance requirement, this is for auxiliary lane. So what is an auxiliary lane? We saw acceleration and deceleration, and I think you must be very familiar with those terms, right? So on these terms you have to provide some super elevation, right? Sorry, side distance, right? Because it is a basic requirement of a highway. At any point on a highway, your the distance visible to you ahead of you should be a minimum side distance. So they say that on these auxiliary lanes, the side distance should be based on a minimum of 7 seconds of travel time. Okay, so this is correct. I just told you the point straight away. Just a second. Yeah, moving on to the next question. Column 1 lists the various elements of an interchange, and column 2 lists the minimum dimensions of these elements. Okay, now if you see sir's slides, this will go for many slides, and I just wanted you to show the wanted to show you the question. So if I try to point out where each point comes, and try to explain each of these, then it is not necessary, right? Because these points do not require much of an explanation, and showing references from sir's slides is going to be quite difficult, but you can easily find these answers in sir's slides, obviously. Okay, so first we will see the first answer to this problem. Length of the deceleration lane for flat conditions. We already saw what a deceleration lane is. So length of the deceleration lane, it has to be 90 meters. Okay, this is in flat conditions. Interchange spacing in underdeveloped areas. What do I mean by interchange spacing? This is my road. Okay, I'm traveling on this road, and here you come across an interchange. Okay, where should you have your next interchange? That is my interchange spacing. Okay, so this has to be at least, so the next interchange which I see should be at least 1 kilometer apart from this. Okay, so this is for underdeveloped areas. Sorry, not 1 kilometer, sorry, I'm sorry, 4.8 kilometers. 1 kilometer is obviously too short. So the answer to this uh, second point is 4.8 kilometers. Vertical clearance at an underpass. So what is vertical clearance and what is an underpass? So you have a road. This is in level with the surface, and you have another road which is perpendicular to it, okay, maybe going through the laptop, okay, which is at a lower level than this road, okay. So this has this is an underpass. Why do I call this as an underpass? Because it will have a headroom, okay. And they say that so this is the vertical clearance for this underpass, and it has to be at least 5.5 meters, okay. It should be able to accommodate the height of the vehicles, right? So it has to be at least 5.5 meters. And paved shoulder width. You know what a paved shoulder is. You know what a shoulder is. And what is a paved shoulder? A shoulder which is paved using a bitumen or concrete is a paved shoulder. So the paved shoulder width has to be 1 meter. So the answer to this is B. Okay. Moving on to the next question. So the maximum length of a weaving section over which merging and diverging movements are defined. Okay. So what is merging? We saw what merging is. I'm traveling on a road, and there's some other road here. If I try to enter this main road, say A, from this road B, then I will kind of merge into this mainstream. So this is called as merging action. Similarly, diverging, this is my road A and this is my road B, okay. And if you wish to travel from shift your direction from A to B, then you will diverge from this road and enter B. So this is my merging action and this is my diverging action. Then what is weaving action? It is a combination of merging and diverging. So what do I mean by this? Let us say I have oh, I'm sorry. Okay, let us say this is my road. If I want, so I'll name these roads as A, B, C and D. And if I'm traveling on road A and I wish to go to road C, then what will I do? I will first make the merging action, right? So I will merge from A and come to this mainstream. Let us call this main road as E. Then from here, after I've merged here into this uh, traffic, I will diverge from this traffic and enter into C. So here I have merged and here I have diverged, okay. So this is nothing but weaving. You kind of weave into you merge and then diverge. So this is the weaving action. Now what exactly is a weaving action? It is the vehicles in the same direction within 2 or more streams, okay, and they try to meet the vehicles in the other stream at small angles, right? They do not meet each other at perpendicular angles, but the angle is kind of reduced, meeting angle, okay, or the angle with which the conflict might occur is small, okay. So this is the weaving action. It is a combination of both merging and diverging. So what is a weaving section then? Weaving section is obviously the location where this movement takes place, okay. So it is the section where, so basically this is my weaving section because it is where, so E is my weaving section. Now you have to provide a limit, so it has a limiting value. The weaving section has a limiting value. So the question is this limiting value. So they are asking you the maximum length of the weaving section over which merging and diverging movements occur is what? Okay. Because if it is more than that, then it will not come under weaving action. It will come under separate merging action and separate diverging action, right? So the maximum length of the weaving section where both merging and diverging are considered to occur together or sequentially is the weaving section, and it should have a maximum length of 450 meters. So the answer to this is 450 meters. Okay. Now moving on to the next question. Examine the following factors. The correct option representing the factors which influence the extent of parking provision in an area is what? So till the last question we were seeing about interchanges. Now we have come to design of parking facilities. Okay, guidelines for the design of, or design of parking facilities. Oh, sorry, design of facilities, and in that we've come across parking. Okay. Now let us first have a general overview of parking, and then we will get into the questions. So parking, if you see, yeah, just a second. Yeah. So parking, if you see, it can be either an on-street parking, an off-street parking, or special parking facility. Okay. So on-street parking, as the name says, on the road itself, by the side of the road, you will provide a space for parking, which you will call it as on-street parking. Off-street parking, as the name says again, it is off the road limits, and we also have special parking. Okay. So if you see IRC SP12, you will be given, you can find the guidelines for parking facilities. So let us see some theory related to parking. So parking can operate based on two types. Okay, one is free parking, as the name says, you are free to park, and paid parking. And yeah, you are supposed to pay to park your vehicles, obviously, right? As the name says. Now let us come to on-street parking, types of parking based on where you park your vehicles. Okay, where you are supposed to park your vehicles. One is on-street parking. On-street parking, when so yeah, so this is my road. This is my curb. Okay, that is the a raised section. You can park your vehicles in this region. In this region. Okay. How you park your vehicles, based on how you park your vehicles, um, there are types based on how you park your vehicles also. Either you can park your cars. Okay, so this is my curb. I can park the cars parallel to the curb, or they can be parked perpendicular to the curb. What is the difference? This will provide, this will give you a lot of space for the vehicles to move, but this maybe it will reduce the space. Okay, that thing is there. Or you can even provide angled parking. Okay, like this. Okay, so this comes under on-street parking. Moving on to off-street parking. So what are the off-street parkings? One is surface car parking. Okay. The other is underground parking. Obviously, all these are not part of the roadway, but they are separate locations allocated for parking vehicles. So one is surface parking, where you park on the surface. If you're traveling, on the road itself, by the side of the road, you might have seen separate area allocated for parking, okay, maybe a ground or somewhere, okay. So that is surface parking. Underground parking, you would have seen in malls, right? Multi-level parking also is yeah, you would have seen in many shopping places, like you have different levels where cars can be parked. You have roof parking, and one is mechanical parking. So what is mechanical parking? Multi-level parking is you are provided, so you will have different levels and you will be provided ramps to access each level. So if you want to park in this level, you will um, travel on a, travel on a ramp and then park your cars in this vehicle. If you want to move on to the next level, then you will again travel on a ramp and move on to the next level. But what a multi-level parking is, sorry, mechanical parking is, um, you will have multiple levels, but you will just go place your car here, and the mechanical system will automatically um, take the car to higher levels. It is basically how a lift, like how a lift works, right? In a lift, you stand and you are taking, you're being taken to different levels or different floors. Whereas for a car, it is just placed in something which is very similar to a lift, okay, by concept, and from there it is taken to different levels, okay. So this is mechanical parking. And special parking facilities, maybe we can say parking for disabilities, which we will see later, okay. um, oh, so examine the following factors, the correct option representing the factors which influence the extent of parking provision in an area. So let us move to this question, okay. So why is a parking needed? If you understand why, that concept, then maybe the influencing factors for parking provision also can be covered, right? So why parking facilities are needed? Because we nowadays everyone owns cars, right? So obviously you have to provide some space for parking all those cars. So parking is because of the higher higher number of or the increase in the number of vehicles which people have started owning. um, so and whenever you go somewhere, okay, unless and until you go from one place to another, or like travel across cities, most of your time your cars will be parked, right? Where will you go most of your time? Either you take your car and either you take your car from your home and then take it to the office, park it there, and then get to the office. So you need a parking there. Either you when you go for shopping, you take your car and then you park it in the shopping mall, right? So most a car is just to help you travel, right? So after that action has been after that action is over, your car has to be put somewhere. It has to rest somewhere, right? It needs a place um, where it can be kept, right? When you're not using it for travel. So most of the times your car or your vehicle is going to be parked, and so you obviously require parking facilities for that, okay. And if you do not say if you do not provide any parking facilities, most of the vehicles tend to park right next to the or on the roadway, thereby decreasing the capacity of the road. Here also in on-street parking also, you would have parked the roads on the roadway, but still, yeah, but still, um, they would have taken care of all that, and that is how they would have designed the parking facility. So that is not an issue. But if you do not provide any kind of facility, then vehicles will randomly park their vehicles on the road, thereby affecting the capacity of the roads. Okay, so um, if you see, what do you think will affect parking? Will my type of vehicle affect parking? Obviously, if it is a two-wheeler parking area, the area required will be less, and if it is a four-wheeler, or if it is a heavy vehicle parking area, then the parking area will be more, right? So types of vehicles, obviously it will have an influence. Now, will land use affect parking? Obviously yes, right? Because if it is a shopping center, obviously you have to provide for parking. Only then the people who have come for shopping will not park their vehicles as and where they want, okay, and thereby affecting the capacity of the roads. So if it is a shopping complex, you will provide parking. If it is a educational institute or an office, you will provide parking. Obviously the area required for parking will depend upon the land use. If it is an educational area, maybe only the teachers or the staff members of the institute might be using um, four-wheelers, right? The others might be using two-wheelers or cycles. Okay, students might be using cycles. So in such a case, you have to provide more parking for cars and more parking for cycles and maybe less parking for cars. Whereas when you come to a shopping recreation area like a shopping center, many people will not prefer coming to shopping centers by cycles. Uh, so they might provide place for cycles, but the area will be very less. Whereas many people tend to come in four-wheelers, so the area required will be more. So obviously the land use will have an influence on the parking provision and implementation of parking policies. So based on whether it is a paid parking or free parking, mostly people tend to go to free parking, right? So if it is the parking provision will also depend on the implementation of such policies. So this is a very simple and kind of a logical question. So the answer to this is 1, 2 and 3, all the three options. Okay. Now moving on to the next question, which is maximum curb length will be occupied if the parking pattern is what? Okay. Just now we saw um, what on-street parking is and how how vehicles can be parked, right? So let us say this is my curb. My vehicles can be parked parallel to the curb. This is called parallel parking. They can be parked perpendicular to the curb. And just note that I'm drawing only 3 vehicles. Okay, I'm there may be a 45-degree and then a 60-degree. Sorry, 60. Okay, kind of more than 45 and less than 90. Okay, pardon my drawing skills. So which one will you occupy? Which one will you think will occupy more curb space? Right? If you see this, one vehicle has occupied only this distance, curb space. Here, one vehicle has occupied this much distance. Let us say this is L1, this is L3, this is 60 degrees angle. Okay, this is L2 and this is L4. So how do you think these distances will vary? L4 greater than L3, greater than L2, greater than L1, right? Because this this kind of parking covers a larger curb distance than compared to all the other 3 cases, right? So this maximum curb length will be occupied if the parking pattern is parallel parking. Okay. So moving on to the next question. Column 1 lists various on-street parking patterns with directional movements, and column 2 lists the width of the circulation area to be provided on side of bay or in between the parking of vehicles. Okay, so we've been asked to match. So I've taken figures from IRC 12, SP 12, and let us see what they've asked and how to answer them. Okay, so they are asking you, they've given you the situation. Where's my pen? Yeah, they've given you the situation, whether it is a bay on one side, whether it is a one-way traffic, or whether it has bays on two sides, whether it has one-way traffic or two-way traffic. What do I mean by bay? So bay is the parking bay. Okay, so this here, it has parking bay only in one side. This is the end of the road. Okay, here the parking bay is on two sides and vehicles are allowed to travel in the center, but it is a one-way traffic. Here the parking bay is two bays, and the vehicles traveling are two-way traffic. Okay, so this is what they've given. So what is the difference between each of these figures? It is just the angle of parking. Okay, so here the angle of parking is 30 degrees. This angle is 30 degrees. Here it is 45 degrees. Here it is 60 degrees, and here it is 90 degrees. Right, 90. Now this distance, which is the area where the vehicles circulate. What do I mean by circulation area? So if you have to park the vehicle, you obviously have to travel some distance. If you have to park a vehicle here, you obviously have to travel some distance and then only put your car for parking, right? So this is the circulation area where vehicles travel. So they've given you the width of the circulation area for each case. Say for 30 degree parking, 45 degree parking, 60 and 90, they've given you the values for each case. So let us first see what they've asked and try to find out from these figures where they come under. Okay. Okay. So 30 degrees, which means it is the first figure, one side bay and one-way traffic. So so what is the circulation area here? So this is the case, one side bay, one-way traffic, 30 degrees. Okay. So it is 3600. So the answer to this is A is 1. Right? Now, what is the next thing that they've asked? 45 degrees, two side bay, two-way traffic. Just a second. Okay. So it is 45 degrees. So this figure, two side bay, two-way traffic. So it is this case. In this case, the width has to be, the width of the circulating circulation area has to be 6300. So the unit is in mm. Okay, which means it is 6.3 meters or 3.6 meters. Okay. Now moving on to the next case, 60 degrees parking, two side, two-way traffic, two side bay, two-way. So it is this case, right? Two-way, two-bay. So it is 6600 mm. Okay. So A is 1, B is 3, C is 4, and then coming to 90 degrees, one side bay and one-way traffic. So this is one side bay. Oh, sorry. Okay, so this is one side bay and one-way traffic. It is 6000 mm. Okay. So D is 2. So the answer to this will be A. Okay, moving on to the next question. If the total number of parking spaces in a parking area is 800, the minimum number of universally accessible parking spaces that must be provided would be what? So what do I mean by universally accessible parking spaces? So a few minutes back I was saying that you should provide parking facilities for disabled people also. So not all the parking areas can be accessed by the disabled people. So you have to make sure that out of say 100 parking spaces totally available, some amount of parking spaces should be designated for disabled people. And why do they call this as universally accessible parking spaces? Is because that parking space can be occupied by uh, people who are physically fit, okay, physically fine, okay. It can be occupied by both those people and people who are physically challenged, okay. Let us not call them disabled, we'll call them as physically challenged. And so yeah, so it will be accessible by both these people, so it is universally accessible. Whereas the remaining spaces might not be accessible by the physically challenged people. So that is why parking spaces which can be accessed by anyone is called as universally accessible parking spaces. Now, if the total number of parking spaces in a parking area is 800, the minimum number which could be universally accessible is what? So I told you, out of 100 parking spaces available, you have to assign some amount to physically challenged people, right? So what is this amount? So as per the code, if you see, if the number of parking spaces is up to 50, then you will provide one universally accessible parking space. If the total number of parking spaces is 50, then you will provide one universally accessible parking space. If the number is from 51 to 400, then you will provide a minimum of 8 parking spaces, okay. It goes by, for 50 it is 1, so for 400 it is 8, so it is increasing proportionally, okay. Now if it is more than 400, okay, you will not increase it by 50. Till 400 you will provide 8, okay. And for the remaining, so if it is 600 is the total thing, I will, for 400 spaces I will provide 8 universally accessible parking spaces, and for remaining 200 I will provide one parking space, one universally accessible parking space per 100 total parking spaces available, normal parking space available, okay. So if you so for 50 it is 1. From 50, if the number is from 51 to 400, if the total parking space is from 51 to 400, then for each 50 parking space you will provide one universally accessible parking space. And if it is more than 400, up to 400 parking spaces, you will provide one universally accessible parking space for every 50 total normal parking space. And for the rest, you will provide one universally accessible parking space for 100 total normal parking space, okay. So if you see this problem, you will understand. So the total parking space is 800. So as you can see, it is more than 400, right? So for 400, I would have provided 8 already, because there are 8 50s in a 400, okay. Now for the remaining 400, okay, I will provide 1 per 100 total normal parking space. So one universally accessible parking space for per 100. So I have 400s in this 400, so I will provide 4 parking space, 4 parking spaces for this additional 400. So how much is the total number of parking spaces? It is 8 plus 4. This is 50 per parking space. I mean 1 per 50 normal parking space, and this is for 1 per 100 normal parking space. So the total, so the answer is 12. You will provide 12 normal universally accessible parking space. Moving on to the next question. The minimum illumination level should be ensured in an should be ensured in an underground parking. So we saw that under off-street parking, underground parking is one type, right? So obviously underground parking has to be provided with an illumination, maybe even during daytime. Unlike surface parking where illumination is provided, illumination is required only illumination is required only at the night time. Illumination will be provided because illumination is always designed for the worst case scenario, which is night time, right? So illumination is required only at the night time for surface parking, maybe. But for underground parking, obviously illumination has to be provided even during daytime. So illumination is an important criteria, and they've asked you what is the minimum illumination level that should be ensured in the underground parking. Okay, if you see sir's slides, it is from minimum of 50 to 75 lux is my minimum illumination. So out of this, 50 is the lowest, so my answer is 50. Okay, moving on to the final question. Okay, in case of tower parking, the number of spaces per floor that are kept vacant to facilitate proper parking operations of a car are what? Okay, so what is a tower parking? It is kind of like a multi-level parking. Okay, in such cases, for each floor, okay, for each floor you have to provide at least 2 vacant parking spaces for vehicles to easily uh, make parking actions. Okay, so it is to facilitate their parking actions. So for each floor you have to leave at least 2 spaces vacant. So this is the answer to this question. So next we will see, the next session will be next Monday, okay, which is 16th. Okay, so we will see that. Okay, so I'm ending the session. Okay, so thank you all.